The chapter name is triangles. What does triangle means? It's a three-sided polygon. A three-sided polygon which has three angles and three vertex, and we should know what are the components of this triangle. The six elements of this triangle is the angles A, B and C are the first three elements, and the other three elements are the sides AB, BC, CA. Okay, and these things we know. This is about this triangle, and what we are going to study in this 9th class triangles means the first thing we are going to discuss about the congruency. Not the first thing, this is the main thing. Congruent means what? Same, like equal, looks like same. So when we can say two geometrical shapes are congruent in general, two geometrical shapes, when those are should be in same shape and that should be in same size. Whether these two condition is satisfied, we can say those two geometrical figures are congruent. For instance, take a square or rectangle, whatever. Square will take. Are they same shape? Yes, this is also square, that is also square. And this square of side 5 centimeter, that is square of side 7 centimeter. It has same shape, but the sides are not equal. Same size stands for the measurement should be equal. So these are not congruent. Suppose in this also the side is 5 centimeter, then we can say these two are congruent. Okay, and this is for square. What about triangles? That is the one which we are talking about right now, which we have to worry about actually. See, the triangles, how do you say two triangles are equal? In the sense congruent. Triangle, this is also triangle, that is also triangle. How do you say these two triangles are congruent? So same shape, that condition is satisfied. The same size means the corresponding sides should be equal. What side should be equal? Corresponding sides. Also, the corresponding angles should be equal. The corresponding sides and the corresponding angles should be equal. When I say corresponding sides, how many sides are we talking about? 3 sides. See, look at these 3 elements. And when I say corresponding angles, how many angles we are talking about? 3. So whenever we compare two triangles, we should compare the 6 elements of both triangle, and those 6 elements should come as equal. Then only we can say the two triangles are congruent. Okay. For example, take this triangle ABC and this triangle PQR. Suppose we are finding that this angle A is equal to angle R, this angle C is equal to angle P, and this angle B is equal to angle Q. Also, the side AC is equal to PR, the side BC is equal to PQ, and the side AB is equal to QR. How to denote the congruency of two triangles? That is denoted by the symbol like this. The symbol name is congruent. How we should read this is congruent to. See, now in the example itself I gave that all the three angles are equal, corresponding angles, the corresponding sides are equal. Now, is it okay to write the triangle ABC is congruent to triangle PQR? Means no, it is not. Why? What's the problem in it? When we say when we write like this, means this A should be equal to P. Is that A equal to P? No. A is equal to R. And this B should be equal to Q. Is that B is equal to Q? Yes. B is equal to, here 3 lines, there are also 3 lines, meaning it is equal. This C is equal to P. Is it? Not only this. This is angle correspondency, angle congruency. Okay. What about these two? AB should be equal to RQ. Is it or not? AB is equal to RQ. Yes, it is true. I will write that better. Angle A should be equal to angle R. Angle B should be equal to angle Q. Angle C should be equal to, not should be, I gave that is equal. Angle C is equal to angle P. And AB is equal to RQ. And the next, BC is equal to QP. Is it or not? BC is equal to QP. And this one, the other one. So AB, BC I said, and then AC is equal to RP. AC is equal to RP. Okay. Now, can you remember what I told when I am starting? This all the elements should be equal. Are they equal? The corresponding elements. This A, B, C are elements of this triangle ABC. This PQR are elements of that triangle. So, element of this triangle should be equal to element of that triangle. Then we can say these two triangles are congruent. But is it okay that we can check all the 6 all the time? Okay. While thinking that, you may think of some examples. See, in your book there are several examples are given. Shall we figure it out whether the triangles are congruent or not and how to mention that? Let me draw one by one and you answer how that congruency is defined. Shall I erase everything? See, the triangle ABC, here A, this is B, this is C. Here 5 centimeter, 4 centimeter, 4.5 centimeter, and another triangle PQR. This is 1, this is 2, this is 3, and here 4 centimeter, 4.5 centimeter, this is 5 centimeter. Now, shall we say these two triangles are congruent? How do we check? All the 6 elements of the triangle. See, we have angle A equals angle P, angle B equals angle Q, and angle C equals angle R. Okay, and the corresponding sides, the another 3 elements. Here 5 centimeter, there also 5 centimeter. That means BC equals RQ, and then here 4.5, there 4.5. 4.5 means AB, there 4.5 means PQ, and four centimeter AC equals PR. See, using this we may define our congruency. Triangle ABC is congruent to triangle PQR. We have AB is equal to PQ, and BC is equal to RQ or QR, and AC is equal to PR. Yes, this is how we should check. Now the other set of triangle DEF. Here angle E is there, here angle F is there, here angle D is there. So here 5 centimeter, here 4 centimeter, here 4.5 centimeter. Now check whether that ABC is congruent to DEF or not. How do you check again? Angle A, okay, then angle B is equal to angle D, angle C is equal to angle E. So we can define our congruency relation that triangle ABC is congruent to triangle FDE, and the other steps we will check AB is equal to FD or not. Yes, this, and the next one DC is equal to DE or not. BC is 5 centimeter, DE is 5 centimeter, and then the other one AC is equal to FE. So these two triangles are congruent. Then on last one, obviously you know that last diagram is not congruent to anything, because all the sides are 5, that is equal to triangle. So now you check this diagram. The triangle MNR, N is 3 lines, M 1 line, R is 2 lines, 4.5 centimeter here, 5 centimeter there, 4 centimeter. Now check whether this triangle PQR is congruent to this or not. If so, how will you denote it? Okay, that is okay, but I told you to compare PQR and this. So triangle PQR is congruent to triangle MNR. How, man? Here R means 2 lines, there R means 3 lines. Yes sir, sides also we should check. Angles also corresponding. See, P is equal to M. Yeah, okay, that is correct. Q is equal to N. Q 2 lines, N 3 lines, bill. Q is equal to R. And that R 2 lines, that is equal to Q. M or Q. Okay. So this is how we should check whether these two triangles are congruent or not. So as we have done this for this all the triangles, it's very tiring process, is it? It's not possible to check all the things all the time. For that, the congruency criteria will help us. Instead of checking all, particular things we'll check and we confirm that these two triangles are congruent. Okay. And before closing this session, I want to raise one question. We are studying about congruency of triangles. Where we are using this actually? In constructions. Yes. Like to calculate some measurements, like how that land will behave, how it will react to the weather. This much height building is already there. So comparatively, the same measurement building shall we build near to that, or shall we build in this soil or not? Those things they will check using this congruency. Also, there is another concept which is way simpler than, or else a byproduct of this is called a similarity. Will help us to build a model of a construction that talks about ratios of the sites and all. That will be studied in the 10th class, not in 9th class. So with this note, we'll conclude this session and we'll start the next section of the congruency criteria. Shall we?